Today's discussion is about work, energy, and power. In our previous classes, we have already discussed what work is, but I shall give a brief review of the previous classes. So, we have already defined work as the product of force, displacement, and the cosine of the angle between the force vector and the displacement vector, which means that if a force acts on a body and it is capable of producing a prominent displacement, then work is defined as the product of the force, the displacement, and the cosine of the angle between the force vector and the displacement vector. So, W equal to Fs cos theta. This can be expressed as F into S cos theta, where S cos theta means it is the component of displacement vector along the force vector. The component of displacement vector along the force vector, which means that if you rotate the displacement vector by an angle theta, the portion of the displacement that aligns itself with force is actually S cos theta. Similarly, we can also write work equal to F cos theta into S. And F cos theta is component of F vector along S vector. That means if the force is rotated by an angle theta, the portion of the force that aligns itself along the displacement is F cos theta. Hence, we can also write F cos theta as the dot product of force and displacement vector. So, what is the dot product of force and displacement vector? In vector algebra, there are two types of products. One is called as the dot product, another is called as the cross product. So, whenever we try to express a scalar quantity in terms of the dot product of two vector quantities, then precisely we get work as the dot product of force and displacement vector. This dot is nothing but it includes the cos theta along with the force and the displacement vector. So just symbolically this is an expression, and the equivalent form that we have to remember is Fs cos theta, because details of vector algebra and dot product and cross product is discussed in class 11. So this is just a symbol for the time being. I have already discussed that if theta is 0 degree, it means that force and displacement are along the same direction, then simply W can be written as F into S, because cos 0 degree is obviously 1, and this is also called as positive work. If theta is 90 degree, because cos 90 is 0, so work will be 0, and if theta is 180 degree, which means that force and displacement are exactly in the opposite directions, then they will be equal to minus Fs, because cos 180 degree is minus 1. I also took several examples related to this. Say for example, positive work, if an object is released from a specific height above the earth's surface, then the force of gravity is doing positive work. In circular motion, the centripetal force is performing 0 work, because the displacement is always perpendicular to the force in case of circular motion. Whenever forces are always trying to retard the motion of an object, say for example friction, the work done against friction is definitely negative, because friction is always opposite to the direction of the motion of a body. Now, work done by force of gravity can be also expressed as W equal to Fs cos 0. Why? Because the force of gravity, that is mg, is along the direction of the displacement, provided the object has been released from some height above the earth's surface. Say that height is h, then we could express F as mg and the displacement S as h. So work done by the force of gravity when an object is released from a specific height h above the earth's surface will be mgh. The units of work and energy are equivalent. The SI unit of work is Newton meter, which is also called as joule. The CTS unit of work is dyne centimeter, which is also called as arc. And you can easily convert joule to work and you will get the result 1 joule as 10 to the power 7 arc. There are other equivalent energy units apart from the SI and the CTS units, and that unit is electron volt. 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Now electron volt is defined in this form. It is the energy possessed by an electron when it is accelerated through a potential difference of 1 volt, and from that the conversion factors will get this result. Similarly, 1 kilowatt hour is also an unit of energy, and that is equal to 3.6 into 10 to the power 6 joule. This can be easily converted. You can refer to any standard textbook. Now we can define power in terms of work also. The power is nothing but it is the rate of doing work. So work done in a given time interval will produce what we call as power. Power is definitely work upon time, the time interval during which the work is being done by the given force. So we already have seen that work is Fs cos theta. So Fs cos theta divided by t. Now S by t is nothing but displacement by time, which is obviously the velocity. So power we can now express as Fv cos theta. And in an equivalent manner, what we wrote in the case of work as F dot S, in this case we can write it as F dot V vector. So dot product of force and velocity will produce the power. We have to just remember P is Fv cos theta because the dot product is elaborately discussed in class 11. The units of power are joule per second, which is popularly called as watt. There are different higher and smaller units of watt. Say for example, megawatt means 10 to the power 6 watt, kilowatt means 10 to the power 3 watt, gigawatt means 10 to the power 9 watt. The smaller units are milliwatt, one small m W. Milliwatt is 10 to the power minus 3 watt, and microwatt or mu W is 10 to the power minus 6 watt. Another commercial unit of power is horsepower, and you have to remember this conversion factor as 1 horsepower equal to 746 watt.